let's look at compound interest. Compound interest is an interest paid on an initial investment called the principal and on previously earned interest. Interest earned is often expressed as an annual percent, but the interest is usually compounded more than once a year. So the exponential growth model, y equals a times 1 plus r raised to the t, must be modified for compound interest problems. So we're going to look at that, compound interest. And consider an initial principal P deposited in an account that pays interest at an annual rate R, expressed as a decimal, compounded n times per year. The amount A in the account after t years is given by this formula. So this is important to have. So A equals P times 1 plus R over n raised to the n times t. So we're going to use that in our next example. We're going to find the balance in an account. You deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. Write interest compounded quarterly. That means it's 4 times per year and the balance after 3 years. So let's identify what we know. So first of all, $9,000, that is P. That's the starting value, 9,000. Then we have, whenever we see percent, that has to do with our R value. So that's 1.46%. But remember, we need to convert that to a decimal. So dividing by 100 or moving the decimal left 2 times, we get 0.0146 is R. Now, compounded quarterly, so that has to do with how many times it's compounded per year. And in this case, it is 4 times per year. Quarterly is 4. And time, it says after 3 years, time is 3. So let's write the general compound interest formula first. A equals P times 1 plus R over N, and then raised to the T. Raised to the n times t. N times t. So t is this color here. So let's go ahead and substitute what we know. So A equals 9,000 times 1 plus 0.0146 divided by 4 raised to the 4 times 3. So let me write down the calculator directions of how you do this. So calculator, so you have to be able to write this first, write the formula. And then so on the calculator, this is what you type. Type in the initial amount, 9,000, parentheses, 1 plus another parentheses, open parentheses, and then type in 0.0146 divided by 4. Close parentheses to enclose the division, and then close the parentheses to include that adding the 1. Then you do the exponent, so that or the y to the x button. And then parentheses, because we need to do the exponent now, parentheses 4 times 3, and then close parentheses, and then equals. So if you type that in correctly, you put inserting the correct amount of parentheses in there, then you should find that A is approximately $9,402.21. So round to 2 decimal places, it is money. So therefore, the final answer is the balance is $9,402.21 after 3 years. So it's getting practice and plugging it in the calculator and getting the right answer and really knowing how to use it. So you want to try this next example here. You deposit $8,600 in an account that pays 1.32% annual interest. Find the balance after 4 years when the interest is compounded quarterly again. So try this out. Okay, trying this out, you should have gotten $9,065.49. So you would plug it into the formula. So that's really important, right? So we're going to be looking for, can you write the formula from the given information? Then you plug it in your calculator. I wrote the calculator directions again. Most important, just to have enough parentheses in there. And then that should be your final answer. And then you write a complete sentence. Now, just to talk about when things are compounded, if it says biannually, for example, Biannually, that is 2 times per year, so that's twice a year. If it's weekly in a year, how many weeks are in a year? That's 52 weeks. And then if it says daily, do you know how many days are in a year? Approximately. That would be 365 days. So then that would be your N value. Okay, so those are the most common ones that you will see: quarterly, biannually, weekly, and daily.